Assalamualaikum and a good day. We are from RY55, group number 2. We'll be presenting the mechanical design and analysis of post-mounting bracket. Our group consists of 3 members, including me. My name is Ahmad Razif bin Rosli and my metric number is 191313235. The rest will introduce themselves later on. There's a total of 14 slides. It includes the front page, introduction, a methodology, result and discussion, and lastly the conclusion. Now let us go to the next presenter.
Okay, Assalamualaikum. My name is Muhammad Firdaus bin Nurizan. My metric number is 191312594. Alright, for my part is introduction. This is a project of a copper alloy with a young modulus of 620 gigapascal was used to make the mountain bracket for this study. And we use SolidWorks and ANSYS, the two type of software that will be used to design this bracket. And the choice of material is made based on how much its weight can support and how well it performs in an open atmosphere. Alright, for the next is objective. Alright, for the objective of this project, the major goal of this study is to select a metallic material for a structure that can withstand a load of 276.6 Newton without fracturing or exhibiting plastic deformation. The next objective is to creating a structure with a mass of less than 3 kg, a factor safety of at least 2.0, and a maximum deflection of not more than 1.5 mm. The last objective is to using a tetrahedral element mesh with a 3.0 mm dimension and limiting the number of mesh or elements employed in the analytical model not more than 120,000. Alright, for the methodology, here is show the step by step in completing the mechanical design and analysis of post-mounting bracket. Alright, firstly, we design the part using a SolidWorks software and then set the material properties data of all the parts. And then next, we import the geometrical part from the SolidWorks and we move it to the ANSYS. After that, we set the material, we set the mesh part, the boundary condition and the fixed support, and then we set the apply load. Lastly, of all steps, we generate the result. Alright, next step of the methodology is the flowchart. Alright, like I say as the step of the methodology. Alright, from the start, SolidWorks model and then the material properties, and then we go to the import model, set material for the model, mesh material, and then set the fixed support, set the load, and then generate the result. And then all the part has been finished.
Alright, now that the methodology is done, we move on to the finite element modeling. So for the first one is the model discretization. The number of elements is 9,260 and the number of knots is 17,783. And for the material properties, the model is made of a copper alloy with the Poisson's ratio of 0.3. The young modulus of the copper alloy is 620 gigapascal. The thermal coefficient for this model is 19 exponent negative 6 per degree Celsius. And lastly, the density of copper alloy is 8,730 kg per meter cube. Okay, next for the boundary conditions. The boundary condition of the copper alloy is applied at the top of the model as shown in the figure like that. And the loads of the mount bracket is pointed at the bottom of the model at the hull. The force that been given is 274.6 Newton.
Assalamualaikum. My name is Shamim bin Muhammad Rozali and I am from RY55. My matrix number is 191312813. So I want to present about result. Linear static analysis, von Mises stress and total deformation. So this is figure of the result. So next, heat thermal stress, von Mises stress and total deformation. So this is figure of result. Next, free vibration. They have 5 results in free vibration. For discussion, linear static analysis, von Mises stress. The maximum stress is 17.523 megapascal. Total deformation. The maximum total deformation is 0.5424 millimeter. The maximum deflection is approved to be 1.5 millimeter less than the benchmark value. Heat thermal stress. The maximum total deformation is 0.55947 millimeter. The maximum deflection is approved to be 1.5 millimeter less than the benchmark value. The front end and the structure is red, indicating a high number of thermal stress. On the other end of the spectrum, the blue contour indicates reduced thermal stress. So, last one for free vibration. Total deformation that represent deformation for mode 1 in bracket sampling bending. The maximum total deformation measured is 49.951 mm at a frequency of 116.91 Hz. Number 2, the total deformation to represent deformation for mode 2 in bracket transverse bending. The maximum total deformation measured was 83.086 mm at a frequency of 362.76 Hz. Number 3, total deformation 3 represent deformation for mode 3 in bracket bending in the middle span. The maximum total deformation measure is 82.125 mm at a frequency of 521.51 Hz. Number 4, total deformation 4 represent deformation for mode 4 in bracket twisting. The maximum total deformation measure is 53.797 mm at a frequency of 1445.1 Hz. Number 5, the last one, total deformation 5 represent deformation for mode 5 in bracket bending at quarter span. The maximum total deformation measure was 53.559 mm at a frequency of 1831.9 Hz. So thank you, that's all from me.
Alright, now for the last part, which is the conclusion. The analysis has led to the conclusion that a real engineering problem can be solved using the finite element method. This analysis concludes that the finite element approach can be used to tackle a real-world engineering problem. The analysis using the finite element method offers more efficient issue solving by using an accurate diagram of the actual thing. The maximum and minimum value for every result, such as temperature and total heat flux, may be clearly determined with a color contour, and the location is also labeled. The ability to study mechanical structures in 3 dimensions, heat transfer analysis. As a result, the objective has been preserved for this laboratory session. Improvements that can be made include enhancing the temperature difference between the object and its surrounding, increasing the coefficient of convective heat transfer, and increasing the surface area of the body. That's all from us, and thank you.